So now we have seen that for the first order type transfer function, the first order type transfer function is given by y of s by x of s is equal to tau s plus 1. Now we have to see based on the input what kind of outputs you get. Okay, if your input, that is your input, if your input is a step input, if your input is given as step response, that is x of t is equal to a step response, then x of s, if x of t is a, then what is x of s? A by s. So this is your input. So y of s by x of s is equal to 1 by tau s plus 1, right? Your input x of s is a by s. So y of s by a by s is equal to 1 by tau s plus 1. So therefore y of s is equal to a by s by tau s plus 1. A by s by tau s plus 1. A by s into tau s plus 1. This can also be written as a by tau by s into s plus 1 by tau. You are taking tau common. You take tau common. Taking tau common in the denominator, you get a by tau by s into s plus 1 by tau is y of s. Now partial fractions. Y of s, this consider this a by tau by s into s plus 1 by tau can be written as a by s plus b by s plus 1 by tau. Right? Splitting into partial fractions. So a into s plus 1 by tau plus b into s by s into s plus 1 by tau. A by tau. S into s plus 1 by tau. So LCM, you take LCM, you get this, right? So now comparing as usual, a by tau is equal to as plus a by tau plus plus bs. These are the functions. Now a by tau is equal to a plus b into s plus a by tau. Now s term, compare, both sides are equal, so compare. S term, is there any s term on left side? No. So a plus b is equal to 0. A by tau is equal to capital A by tau. So tau gets cancelled. So small a is equal to capital A. So if small a is equal to capital A, b will be minus a. B will be minus a. Substituting in this equation, you get b as minus a. Now this a and b value you substitute in this transfer, in this function, you get y of s is equal to a by s. What is a value? Capital A by s. What is b value? Minus capital A. So minus a by s plus 1 by tau. So a you can take common, 1 by s minus 1 by s plus 1 by tau. This is your y of s. Now what is your output you get? What kind of output means? You have to find the y of t. Input is in terms of step input. So that is nothing but x of t is equal to a. Now you have to find what kind of output you get. So y of t you have to calculate. A into Laplace transform. That is you are applying Laplace transform. That means you are applying Laplace transform. Laplace transform of 1 by s, 1. 1 by s plus 1 by tau. So 1 by s plus a. What is 1 by s plus a? E power minus at. So e power minus a is nothing but 1 by tau into t. So therefore y of t is equal to a into 1 minus e power minus t by tau. So this is what is the transfer function output when you are giving step input. So step input means x of t is equal to a, x of s is equal to a by s. You will substitute in place of x of s a by s and put y of s is equal to a tau by s plus. So you get a by s into tau s plus 1 as y of s. Now take tau common in the denominator. So a by tau. So I am writing it as in the numerator complete part. A by tau divided by s into s plus 1 by tau. Now splitting this into partial fractions. So you get small a and small b as capital A and minus a respectively. Substituting that, you get y of s is equal to a into 1 minus s by 1 by s plus 1 by tau. Now if you apply Laplace transform to that, I mean inverse Laplace transform to that, you get y of t is equal to a into e power minus a into 1 minus e power minus t by tau. So this is when you get step response. That is nothing but your response will be exponential output you get, right? So you see here, your input is this. This is your input, step input. For that you are getting the output as so initially at from this you have certain assumptions that will be done. I mean certain observations you have. First one, at t is equal to tau, your response will read 63.2% of its ultimate value. Your ultimate value is 100. Your boiling point is 100, right, for water. So at t is equal to tau, when that time will be equal to tau minutes or tau seconds, then it will read 63.2 degrees Celsius, because your ultimate thermometer reading is 100 degrees, right? Let us say for boiling point of water, 100 degrees is your ultimate required reading. So when that time will be equal to tau minutes or tau seconds, whatever parameter time units you are considering, it will read 63.2% of its ultimate value. What is ultimate value? 100. 63.2% means 63.2 degrees you will get when t is equal to tau. When t is equal to 2 tau, it reads 86.5%. When t is equal to 3 tau, it reads 95%. And when t is equal to 4 tau, it reads 98% of its ultimate value. So at t is equal to tau, it will read 63.2% of its ultimate value. At t is equal to 2 tau, it reads 86.5% of its ultimate value. At t is equal to 3 tau, it reads 95%. At t is equal to 4 tau, it reads 98% of its ultimate value. Second observation is that initially the slope is equal to 1, right? Initially the slope is equal to 1 at the origin. At the origin, if you take, initially you can see here from the graph, their slope is equal to 1. Their slope is equal to 1. And if it is continued with the same response, initially you can see here the slope is 1, right? If it is continued with the same response, then at t is equal to tau only you get 100% reading. Your process completes there. Actually, it is what it is reading. It is reading 63.2 of its ultimate value, because there is some change in the response. If it is the same response is followed throughout the process, then within t is equal to tau only it will read 100% of its value. The process gets complete. Okay. The process gets complete. And now here this A is nothing but amplitude. A is nothing but amplitude. So this is an exponential curve. It is yt by A. So any function if it is having certain magnitude A, if the function has, your input function has certain magnitude A, then you will divide this ordinate by A. This ordinate y-axis by A function, by a value of A to plot. Okay. Whenever you are having certain magnitude for your input, if there is certain magnitude of the input, in the form of A, then always you will multiply with 1 by A in the ordinate or divide the ordinate, or that is your ordinate is nothing but y-axis by the value of A. This is the step response.